All right, so in this video, we're going to go over some ions, isotopes, and some proton, electron, neutron counting. And so kind of forgive me on this rudimentary drawing. I was having some technical difficulties on getting a picture uploaded to this. So just kind of bear with me. So we're just going to kind of start off just looking at the atom and just starting and labeling what's there. Okay, so our first thing we have is, as you can see from these awesome red circles in the middle, okay, so this would be a proton. So protons, as sure you can see, and you guessed it, protons has a positive charge. So the way I think of that is proton starts with a P, so it has a positive charge. Okay, so remember these are located inside the nucleus. What else is also included in the nucleus is our neutron. Okay, so neutron you gotta think as neutral, so this would have no charge. And our last thing to label on here would be these nice little dots on the outside. These would be our electrons. Okay, so electrons are characterized by a negative charge, and they are found on these energy levels in the electron cloud, so they are not in the nucleus. So only the protons and neutrons are located inside the nucleus. Okay, so next we're going to do is we're just going to try to identify this atom. Okay, so the way we identify an atom, okay, is the number of protons. The number of protons will tell me exactly what it is. Okay, so if I look and I count, I have 5 protons in this atom. So that means my atomic number is 5. So you would need your periodic table to reference this. So you would look up the number 5, the atomic number 5 on the periodic table, and that would give me boron. So this is the atom for boron. Okay, so now we need to see is this an ion or is it neutral? Okay, so what an ion is, it's an atom with a charge on it. So it could be a positive charge or negative charge depending on how many electrons we have compared to protons. Okay, if it has the exact same amount of protons and protons and electrons, then it would be a neutral charge because you have the right amount of positives and the right amount of negatives where they balance each other out. So on this one, we're going to see, is this balanced out or are we going to have a charge which makes it an ion? So if I look, I have 5 protons, so that gives me, 5 protons gives me a 5 plus charge. Okay, now let's count my electrons. Okay, I have 1, 2, 3, 4, 5. I have 5 electrons. So that gives me a negative 5 charge. So these cancel each other out. So this would be considered a neutral atom. Okay, so if protons and electrons balance out, that is considered a neutral atom and is no longer considered an ion. Okay, so let's do a little more practice with that. So I'm not going to draw any more atoms, but I will give you the pin numbers. So these should get real familiar. So our pin numbers, so protons, electrons, neutrons. Okay, so my first example is I have 15 protons, I have 16 electrons, and I have 15 neutrons. Okay, so first thing I see is we have 15 protons. So which element would this be? So you would look up the number 15 on the periodic table, and this would be phosphorus. Okay, so again, protons determine the atomic number, so you would simply look up the atomic number on the periodic table, and this is a phosphorus atom. So now we want to know, is this neutral? Okay, does it have a positive charge or a negative charge? Okay, so let's look. I have 15 positive charges, okay, because I have 15 protons, and I have 16 negative charges. Okay, so that means I have a slightly more negative charge. Okay, so when it comes to ions, we have 2 possibilities. You have a cation and you have an anion. So cation, the way I remember that, it has a nice T in the center. Okay, which reminds me of a positive. Okay, so that's if we had a positive charge, you would be a cation. If you have a negative charge, I think of anion, a negative, anion, it has a negative charge. Okay, so if I look at this phosphorus atom, I have one more electron, which is going to make me a negative atom. Okay, so negatively charged ion. So this would be considered an anion. Okay, so let's try another example. I'm going to do my pin number. So I have 20 protons, 20 electrons, and 21 neutrons. Okay, so let's look up what kind of atom it is, which element it is. So I would look up the number 20 on the periodic table, and that gives me calcium. Now let's look. So I have 20 protons, so that gives me 20 positive charges. And then I have 20 electrons, so 20 negative charges. So they are balanced out. So this would just be considered neutral. Okay, so if they're balanced out, it's no longer considered an ion, and it is just a neutral atom. So let me flip that a little bit. I'm going to do P equals 20, E equals 19, and N equals 21. So pretty much the same thing as the last example, but now I've got a difference in protons and electrons. So we're still dealing with calcium because my protons didn't change. Okay, so that is one thing to remember is you cannot change protons. It can be done through things like decay and stuff like that, but if you change protons, you will change the element itself. It will no longer be calcium if I change that protons. Okay, so what can change is number of neutrons, which is an isotope, which we'll go over that in just a second, and electrons can change, so they can come and go. Okay, so my positive charges, I have 20 positive charges, and I have 19 negative charges. So that means I'm going to have a slightly more positive charge. Okay, so this calcium is now considered an ion. Okay, so remember, if it's a positive charge, this would be considered a cation. Okay, so those were just some brief examples there. So let's go on and do some more stuff. So now let's play around with counting electrons and determining the charges and what they would look like. So my first example I'm going to do is going to be phosphorus with a 3- charge. Okay, so if this phosphorus was neutral, it would just simply be a P. Okay, so that is the abbreviation you would find on the periodic table. But this example I gave you has a charge on it. Okay, so this charge right here, I have a 3 negative charge on it. So that means I have 3 extra electrons. Okay, so if I look up phosphorus, phosphorus has 15 protons. Okay, so I'm going to spell this out. So phosphorus has 15 protons. Now, in a neutral atom, phosphorus would have 15 electrons. Okay, so when an atom is neutral, protons and electrons will be the same because you remember that they balance each other out, so there is no charge. But we have a 3- charge here. So if I have 3 extra electrons, I'm going to add 3 to that 15. So that means this phosphorus has 18 electrons. And I use that's my abbreviation for electrons, is just an E with a minus sign. So if I asked you how many electrons would this phosphorus atom have, you would tell me 18 electrons. So let's do another example. I have K plus 1. Okay, so this K is potassium. So you would find that on the periodic table. And so potassium, so I'm going to spell it out. So potassium, okay, has 19 protons. Okay, so in a neutral potassium, you would have 19 electrons. But this is not neutral. I have a slightly more positive charge to this. So that means I'm missing 1 electron. Okay, so if I'm more positive, that means I've got more protons than I'd have electrons. Okay, so I'm missing 1 electron. So what I'm going to do is I'm going to minus 1 electron. Okay, so this particular atom would have 18 electrons. Okay, let me circle that. So this is good to know because remember, protons are different. Okay, so phosphorus has 15 protons, potassium has 19 protons, so they are different. Okay, you can have the same number of electrons and still be different atoms. Okay, so the only thing that really differs, that determines elements, is the number of protons. Okay, so let's do another example. So another example, I have our strontium 2+. Okay, so strontium, if I would look that up, so strontium, would have 38 protons. Okay, and in a neutral atom, it would have 38 electrons. Now I have a positive 2 charge, so that means I've got 2 more protons than I do electrons. I can't change protons, but I can change electrons. So that means I'm missing 2 electrons. So what I'm going to do is I'm going to minus 2 from that 38. So this would have 36 electrons. Okay, let's do one more for good measure. I have C with a 4-. Okay, so this would be considered an anion because it has a negative charge. The last example, strontium, would be considered a cation because it has a positive charge. Okay, so remember, cation is a positive charge, anion is a negative charge. Okay, so let's get back to this. So this is carbon. Okay, so I'd look up carbon, which would be abbreviated with just the capital C. Carbon has 6 protons because the atomic number is 6. Now in a neutral atom, you would have 6 electrons. But this is not neutral. We have a negative charge. Okay, so I have 4 negative charges. That means I have 4 extra electrons. So 4 extra electrons. Okay, so that's what I'm going to do is I'm going to add those 4 to that 6 that would have been in a neutral atom. So that means this one would have 10 electrons. Oops, change my color real quick. Okay, so this would be considered, and I'm just going to go back and fix these. I'm going to tell you what they are. So this would be an anion because it has a negative charge. Okay, this would be a cation. Okay, because we had a +2 charge. This would be a cation because it has a +1 charge. And then this one would be an anion because I have a negative charge. Okay, so that was a little practice on just counting electrons if there's a charge and determining how many there would be. Okay, so remember, if it was neutral, it would just equal the exact same amount of protons. So I'm just going to give you an example real quick of just a neutral one, just so you can see it real quick. So if I just had carbon, there's no charge right here, nothing. Okay, it would have 6 protons, and it would simply have 6 electrons. And this would just be considered neutral. Okay, so remember, we do not change the number of protons, we only change the number of electrons. If you change the number of protons, you are no longer dealing with that element. So if I had 5 protons, I'm now considered boron. I'm no longer considered carbon, so we don't want to do that. So now let's take a look at some isotopes and how we can give the pin numbers for each. Okay, so I'm going to give you a few examples. I have selenium, so I'm going to do 128, selenium, and a 52. Okay, so remember, this is isotopic notation. Okay, so you have the element. So I'm going to go through and do a real quick labeling here. So this is the element itself, so the abbreviation. This number up top is my mass number. Okay, my mass number, I'm going to put this in red because a lot of people kind of forget this. Mass number simply equals protons plus neutrons. Okay, so they determine the main mass of this atom. Because remember, electrons are very, 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 very small, so their mass really does not affect it that much. So your main meat of the atom is considered the protons and neutrons. So your mass number is on the top left, and that is protons plus neutrons. Okay, so this bottom number, change my color, so this bottom number right here is my atomic number, which equals, your atomic number equals your number of protons. Okay, so this is isotopic notation. Okay, we'll go over an example here in a second of the actual hyphen notation, where we actually spell out the name, give the mass number, but for now, we're just doing isotopic notation. So if I wanted to determine the pin number of this, so let me change up my color real quick. Don't want to highlight, I want to erase. So we're going to do our pin number. Okay, so protons is easy. It's simply our atomic number that's on the bottom left. Okay, so that would be just simply 52. Okay, if there is no charge here, so as you can see, there is no charge on this tellurium. Okay, so it is considered neutral. If it is neutral, your electrons are exactly the same as your protons. Now to find neutrons, all you have to do is subtract this bottom number from the top number. So you're going to do 128 minus 52. So your mass number minus protons will give you your neutrons. Okay, so 128 minus 52 gives me 76. Okay, that is it. So now let's give you another example. So I've got 28, 14. There's going to be silicone, so we're playing with silicone. And we have a 4 plus charge. Okay, so now we're dealing with an ion because it has a charge. And we're going to go through and we're going to do the exact same thing. So we're going to do our pin. Okay, so protons again is easy. It's just simply that atomic number on the bottom left. So that would be 14. Okay, electrons. So now this is where it switches up. Okay, if this was neutral, it would be 14 electrons. But I have a positive 4 charge. So what that means is I have 4 more protons than electrons. Okay, because remember, protons are charged positively. So in order for me to be charged positively, that means I have to be missing electrons. So that means I'm missing 4. So what I'm going to do is 14 minus 4, and that's going to give me 10 electrons. Now to find neutrons, all I have to do is just subtract those numbers. So your mass number minus your protons or your atomic number. 28 minus 14 simply gives me 14 neutrons. Okay, so let's do one more example. I'm going to do this. I'm going to say arsenic 75. Okay, so this is hyphen notation. So I'm going to put this in a different color. So this is hyphen, oops, if I can spell. Hyphen, man, I almost did it again. Notation. Okay, so this is simply the name, and this is the mass number. Okay, back up here, this is considered isotopic notation. You will need to know both and how to navigate both. Okay, so this one is hyphen notation, so arsenic 75, and we're still going to do our pin numbers. So P, E, N. Okay, so what you would use is your periodic table for this. Okay, so we will give you a periodic table. You do not have to memorize what the atomic number of arsenic is. So if I looked up arsenic on the periodic table, it would have the atomic number of 33. Okay, now we would give you a charge, and this one does not have a charge, so that means it is neutral. So that means my electrons are the same. Okay, lastly, my number of neutrons is simple. All I got to do is my mass number minus my number of protons. So mass number would be 75 minus my number of protons. Okay, and that gives me 42. So my neutrons would be 42. And that is it.